UK now, so we'll get going for everybody. Hi everyone, welcome to the first Golang Live event of 2021. My name, for those of you who don't know, is Jake O'Regan. I'm the Golang specialist recruiter over at Amicus Recruitment for Germany. We cover roles for Golang positions in Germany, London and Amsterdam. So I am delighted to be joined by Sudersen for the second time in Golang Live. Sudersen is the senior software engineer over at Delivery Hero in Berlin and a Golang specialist himself. So it's titled today Golang Live Context 101 with Golang. As always, feel free to ask any questions throughout. I'll interrupt Sudersen as long as he's not mid-sentence, but there will also be time at the end, but we will try and make it as interactive as possible for everybody. It should last around 45 minutes this evening. So yeah, over to you, Sudersen.
Thank you, Jake. Hi guys, this is Sudersen. I work at Delivery as introduced by Jake. I've been working in Golang for around 5 years now. And this topic is, if you're familiar to Golang, you might know it, but I would get into more niche details into it through this 40 minutes or so what we have. So let's get started. I'll be sharing my screen now.
Yeah.
Are you able to see my slide?
Yes.
Yes. So this is about context 101 with Golang. And let's get into it. 2020, quite a year, right? We all know how it was and what it is about. But if you're one of those who were born yesterday, you might not know what is 2020 about. And that's a set context here, as in, unless you have the context, you may not know what is 2020. And this is precisely what we are talking, unless you have talking about this. And this is what this library does. It sets the context to the request, to the function calls, and et cetera, that you have. So let's get right into it. What are the significance of this context library is about? First and foremost, what it does is it sets the scope to the request that you send over a function call. Usually, it can work across API boundaries as it's meant to. And then to other function, what it does is it can do the cancellation. It can cancel in some ways that we'll get into more details in coming slides. And then it's also useful in setting the deadline to the request that you have, making it time bound. You can set a deadline or you can set a timeout. A deadline is a hard deadline, saying a precise amount, precise time point in the future. And then timeout is a relativistic term from now. So these are the three significance of the request of the context library. So let's get into a bit theory part of it. So in this context lab, in these slides, how I have structured this slides are, first we'll go into a bit of brush up. You may know it or may not know it. It's good to cover a few basics, and then we'll get into a few use cases. What are the use case? And that would give you an idea. If you face some kind of a use case, you can identify the pattern and apply the context in that way for your applications. It's not just limited to that. Of course, it can go beyond that as well. But these are just the building blocks of it. So the text definition of context is it carries the request scope values. You can have deadline and timeouts, and you can also have a way to cancel cancellation signal across the API boundaries. So this is the textbook definition of the context. So using context, you can have a request scoped, you can have some time boundedness, and you can have a way to cancel. So these are the three functions of the context library. This is what it is meant for. And the very major aspect of it is that since you're moving this context across the API boundaries, you need not worry that it's going to be unsafe. It's 100% concurrency safe. You can have multiple go returns using this context. You can pass it around without any worry about it being facing any adverse effects of the concurrency. And as well, the another fact of another thing about the context is that it's immutable. You can always add, but you cannot take out the values. So that's how it is. So let's get into a bit of dissection of what this context is all about. Context technically is an interface. We have certain methods, and those are implemented using the same library, of course. So it has 4 methods precisely. First is the done method. And if you look at this signature, this is a receive channel, as in you can always pass in some signals, but you cannot, you can always listen to some signals, but you cannot pass any signal. So this is meant for the called function or called method that you have. So we'll get into more details on what this done does, but of course, this is for the called method that we have. The second thing is that, and how do we pass the signal? The another detail about on top of the done is that the signal would be passed using by closing this channel itself, which would be done by the calling. We'll get into more details, no worries on that. And then the next is the error. The error would give you what kind of error that could have happened and why the done is being called. So when a context is getting canceled, then you would be using these 2 methods. We'll get into more details on the cancellation aspects later, but these 2 are majorly more of this one. And then we have something called as deadline that we discussed, that how do we keep a context time bound? We're gonna set a deadline here, easy, and then we're done with it. And then this is another feature, which is the value. We have certain kind of key value that we want to pass around. We're gonna set it here. And obviously it is set somewhere else. You can only read through it. You can say key A and get the value. If the key A doesn't exist, you get nil. So these are the 4 methods that a context has, and it could be implemented however it's needed, but there is a standard way of supplied through the core library itself. So we'll get into more details on that. So the another thing is that this is the context, and we have certain things called as a root context or a parent context and the derived context. A derived context is directly the child, the descendant of the parent context. You can use a parent context to derive some kind of context and etc. As you see that this forms a tree. You would have some kind of a parent, you would have a children, and this children can be further extended over to the another context. And we have this entire tree going on from there. So a derived context is basically whatever you take it as an extension or the current context that we have. So far, so good. And one thing to, one takeaway of the derived context is that if you cancel the parent context, all the children's would be canceled. So that's the important point, takeaway of it. It's a cascade effect, as in you kill the parent, all the children who are descended from that would be canceled. So this is the embedding rule that would be applied on the derived context, and it's only for the cancellation. Then let's get into the square one, which is the root context. It's called root context, it's called parent context, but yeah, you get the point. It's a starting point. It will not have, so what is a root context? Usually a root context is, we use this this function supplied by the context library itself, which is background. And as this background is implied, it can never be canceled. You don't have a way to cancel it. There is no cancellation as such on this context. You cannot have a deadline. You cannot pass any values. So it's 100% nil context. There is nothing in it. It's just a context which is existing as a top level one. And there won't be anything be done. So where do we use this background context? You can use it almost at any place that you want, where you just want some kind of a context being passed, some kind of a long living context that you want. Or if you're starting some kind of an application, you'll have a background context there. There is another context which I didn't bother to put it in to this slide because it's usually not meant for the production use cases. It's called as context.todo. This kind of context is used where certain API is incomplete or you're not sure what to do, but highly recommended don't use that to-do context if you come across that. You just use background or try to implement and get it closer as possible there. So we'll get into more details on the root context here. So how do we use the root context? You can always import that context library now. It's a part of core Golang library right now. So you can use a context and call the background. And this is how the root context is. It's the basic context you can ever have. And disregard this once. Root context is a basic context. You define it. You can use it and supply it however you want. But usually the fun part is deriving this context and using it. There's where the entire fun lies in. So we'll get into more details on that. So this is the first derived context that we're looking at. So far, I'll just recap what we are looking at now. So broadly speaking, a context has two things. One is the root context, and then is the derived context. A root context is the simplest form of context that could ever exist. It cannot be canceled. It cannot have any values. It doesn't have any deadline. It's a basic one. It's the starting point. So now we are looking at the cancellation context with cancel. This is what it is called. And what do we have here? So if you look at the function signature, it provides us a way to accept the parent context, the root context. And it returns back two things. One is the derived context, with the context with cancellation itself, and the cancellation method, cancellation function more often. And this cancellation function would be used by the calling method. We'll get into more details to cancel the supplied context, which is this. And the second one is with timeout. Here we have some kind of a parent context. Of course, the signature is almost the same. But a little bit of difference is that we would supply some kind of a timeout here. And then we get back both same things. This derived context would be with the timeout, and we have cancellation as well on top of it. So we have, you can take it like this. With timeout gives you two ways of canceling a context, basically. Bounded by time, and also have this cancellation to cancel it. So we'll get into more details on that. So let's look at the first example that we have, which is the timeout context. Often, this is a very mainstream use case that I'm talking about. Often you will have some kind of client who might have some kind of server interaction happening. Your client is always time bounded. You may not like to have this client to exceed a specific timeout, say 2 seconds, say 5 seconds, but you don't want it to go beyond that because it would be stuck. You don't want it to be stuck forever, basically. That's what, there's where the time boundedness comes in. And in this demonstration, this pattern is for canceling any call which exceeds a particular amount of time. So how do we, so I would go through the details on that. How did I lay this out? The first thing is that let's look at how do we use this timeout feature here. We have a HTTP client. We have a request being formed here. We are hitting some kind of HTTP endpoint that we have available. And then we are setting a timeout context here. And as you notice this, we have cancellation as well. And this is a differ. So what it means is that as soon as this function block is exiting, you would have this being called and it would cancel. So what this means in overall is that this context is bound to cancel within the set timeout or the end of function call, whichever is the earliest. So this is how we are setting it. And then we are forming this request with the context, of course. And then we are supplying this request. This timeout context is supplied to the request. And then we are supplying the client the request and getting the response here. And that's all. So all we are trying to do here is that we are going to supply some kind of a timeout in the request itself, in the HTTP request, and expect the server to respond within that supplied timeout. If it is not, it would get canceled. That's what we're trying to demonstrate here. If you look at the description here, we have set a very aggressive timeout of 1 microsecond. There are hardly any endpoint responding within this time frame, with this timeout, of course. Unless you are using some kind of hi-fi 5G, it's nearly impossible to achieve this with the current networks that we have. So in this demonstration, this is bound to fail because of the timeout being exceeded, because the endpoint is never going to reply back in 1 microsecond that we have set. So I'm trying to run it, and of course you see the panic. It's because I have set the panic here. Of course, this is a bad example of setting how to be write to production, but for the demonstration, I use the panic. Usually log the error here. If you look at the log, it says that context line is exceeded. Here, this functionality demonstrates that context conveys this to the request client, and just terminates the request without us doing any more implementation on top of it. It just does it just by supplying the context. Just moving on to the other demonstration. Here, we're trying to demonstrate the vice versa of it, as in we have this timeout being breached, and that's why the request got canceled. Now we have a timeout whereby we are setting it to 10 seconds. And then we're going to see if this is still working or not. Of course, the expected behavior here is that it's 10 seconds is liberal enough for any endpoint to respond back. And here we will have some kind of a response because we're waiting for 10 seconds here. Basically, the structure is just the same. I'm just swapping 1 microsecond with 10 seconds.
Sudersen, just had a question come through, if it's okay to jump in.
Yep.
Okay, so this one's from Ivan. Ivan, thank you very much for the question. He just says simply, if the context times out, then I don't need to cancel it, right?
Yes.
Okay.
You don't need to cancel it, but it would be a better practice that you always have that cancellation, because timeout is a very relative term. Today's timeout, times of today, but tomorrow they made their API better, then you have to still handle that case. So it's always a best practice to cancel it. Another aspect is that the cancellation is a direct indicator for the context to release the resources. So yeah, you don't have to, but it's good you do it to release the resources. And and the point of cancellation is that we want the earliest result, whichever is better. So it serves as the second level for it. So in terms of defensive practices, in terms of best practices, it's always better you cancel that. Yeah. So I guess I would move on to my next use case. Here, I mean, we might be wondering, we had a timeout one. This deadline is just a repackage of the timeout. Here we used to say we want to wait for 10 seconds or 1 microsecond, etc., etc. Here we set a very strict deadline saying UTC this time it will not. That's all. So it's just a repackage. You supply some time point in the future. If you supply in the past, it's canceled right away. So you supply something in the future, and then it would work as we demonstrated in with deadline. That's all. Basically, it's just a repackage, nothing different here. So I would move on with the next interesting context that we have. It's the cancel. So it's the cancel now. So now in this cancellation, so I would describe a bit of use case here. So let's say you are having some kind of a search engine, and you return back certain results in a stipulated time, let's say 2 seconds. But just returning the results is not good enough, right? Sometimes we might need some metadata, some additional information on top of it. Of course, these additional informations are feather on the hat or something like that, but it always adds a value, but it's not an important value. It's not a core feature, it's a subordinate feature, but it's good to have. And often most of the products that we have right now are such. So in such use cases, we can exploit this feature here, whereby we have two parallel calls happening. We are keeping one call as main, and we are waiting for the second subordinate call till the main call is finishing. And if this subordinate call is gets finished or gets executed by the time the main call is finished, we can include that result into our final result. Otherwise, we can skip it. Something like this is the basic pattern of it. So here in this demonstration, I'll just go through a little bit of details what we're trying to demonstrate here. We have this is a demonstration basically. So we have something called as main operation. We have something called as optional operation, and we are setting the cancellation context in this way. Of course, if you can note here, we are supplying a root context here. We are getting this cancel method. This is a cancel method. Calling this method would cancel this context. And this context is supplied in both of this. Basically, it's supplied in optional, it's supplied in main. But the key are, the trick lies in supplying the cancel in the main alone, because main holds the remote control. Basically, this cancel method, whoever possesses it is possessing the key to cancel the context. And you're not going to pass it to any random methods. We are only going to pass it who is meant to cancel the request. For example, it could be your client, which could hold this key and call this cancel. So if you look at the main method, we have, I just set this to 2 seconds. You might have some long running execution, which might take 2 seconds at most. And then the main operation is complete. It would call the cancel. And as soon as this cancellation is called, let's dig into the subordinate one. In this subordinate, so usually the cancellation context pairs up well with the select. This select is usually listening to this context done channel. Just a quick refresher. I'll go into reiteration one more time. So this cancellation done, as we described before, is a receiving channel, which would be listened by the by the executing method, right? So whoever has this, usually this channel is a way of communicating the signal that you have to terminate yourself. Basically that. So usually this is supplied to the executing method, and usually the key is kept with the main method. So the subordinate uses this done as an indicator to cancel the request, and this main would hold it as a remote, basically. So if you look at this example, here we have this done being listened here, that's all. And this select would ensure that one of this, whichever is first, it would exit, it would select that one and then exit. For example, if this done is called before this slip is done, we basically have a termination of this request, and then it will return back from there. The vice versa would be if this execution happens before it, then we would have exit from here. So exit from here would signify that the operation is complete. The exit from here would signify that the operation is canceled, basically. So this is what we are trying to demonstrate. In this demonstration, if you're looking at this optional one, we have 3 seconds for this to execute. We have 2 seconds for this to execute. So obviously the optional one is going to get canceled because it's taking 3 seconds here in this demonstration. So I'll try to execute this and see how it goes. So if we look at here, the main operation is complete. And then we have an early cancellation by the main operation of the optional operation. So basically it's a 3-way part whereby we define the context first. We have the remote with the main. We have the done being listened by the optional one, and then that's how the execution happens. Moving on to the vice versa demonstration, whereby
Sorry,
yes,
Sudersen, can I just interrupt again? I do apologise. I just had a couple of questions come through there.
yes.
You may have answered them throughout the slide as they came throughout, so I just didn't want to interrupt you in the middle of it. But first one's from Sunny. What happens if we have the same time sleep and context timeout? Is the result the same?
If we have same time sleep in this one.
So what happens if we have the same time sleep and context timeout? Is the result the same?
Okay. So if you're talking about same time sleep, of course, the result would be unpredictable. We may never know which one is executing faster or slower, because the sleep is always having some kind of variableness attached to it. It goes deep inside the code itself, and based on the priority, it works as well. So the result would be unpredictable in that case if you have the same time sleep in that case.
Perfect. Thank you. There was just one more as well. If it was what happens if the CTX done is not handled in optional operation?
Basically, it won't work. So of course, if it's not handled, it won't work. But the key here is that we are trying to exploit that feature. And yeah, the key is that. So if you want to have your endpoint have that functionality, have your API have that functionality, you supply and handle that, and it will work as you expect it to work.
Perfect. Thank you.
All right. So going to the vice versa demonstration of this. Basically, it's a known fact that you have this optional one also working now, because this optional one is faster than the main one. Just to give us a touch up. All right, so this is how the cancellation works. But I would rather suggest that in certain use cases like this, you can always go with the timeout. Always have some kind of a time padding as the final backup, then have a cancellation trigger here. The main crux of where we can use the cancel is in the next slides, which I'm going to demonstrate. So another function that we have with the context is that you can supply values. You can send values. You can send the prominent use cases for this is you can send the session secret or something like that in the context is. You can send the user ID, stuff like that to the bag. And the most popular use case is sending the trace ID as well, so that you can trace and have some observability over your endpoint. So here's where the with value comes in. It's basically you feed in the context, you feed in the key, you feed in the value. That's all it does. And it gives you the context with filled in value, so that whoever receives the context can just call the value and with the key supplied in it and get the value. So it's just a read only for the other end. Here you can supply the value. This is one. And how we're going to use it. So one of the use cases that I was just describing, you take the context, you supply the user ID, you supply the key, you supply the user ID itself, and form a context and pass it to the method that you intend to have this value. One of the advantages is that the other end can only read the value. They cannot mutate or do any changes to that value. So one of the advantages, clear advantages of using value is this, but we'll get into little harder parts. So the value, as we see, is that we can pass anything. It's an interface. You look at here, it's an interface. It comes with an advantage and disadvantage in itself. Advantage being you can supply literally anything that you can have in Golang. Of course, it has to be marshallable to be at least. The disadvantage is that you lose the staticness. It's not if you supply an int, it can be interpreted as whatever. You don't have a way to interpret it in the right way at the other end because it's an interface. It gets converted to an interface. So a few of the best practices with the value is that it should be always just for informing, not for controlling. To be clear, what informing means is that you can say that the user ID is this, but you should not base your business operations and put if else blocking and conditions based on what value we supply in the context. That would be a clear anti-pattern. And also, it should be scope bounded. You should never pass a value in the context which should be living longer than the request itself. For example, when you supply a user ID in the context, it is meant only for that request. But if you supply some kind of variables which might go beyond that request itself, those are not meant. For example, if you're supplying certain kind of application parameter through that, which are not just bound to that request, or should not be sent. Of course, it could be exploited, but that's also another anti-pattern with it. Then, now going on to the real use case where the cancellation could be really helpful for the applications that we build. It's this use case whereby we have a graceful shutdown. It's one of the tricky subjects. Of course, we have many different ways of doing it. There are tons of libraries out there which does this for us. But of course, if you're pairing it with some kind of HTTP server, it goes on well as well. There is already something already here. So I'll get into a bit of details on how we go through this. Here, if you look at, this is the main starting point of entire Go execution. Here we have a signal channel. This listens to the OS signals that we do on the program itself. And here we are looking for SIG-int signal through this notifying. And then we are defining a cancellation context here, right? Then, now, you can forget about this part. All it does is that if we apply some kind of kill sig term, a sig-int, or some kind of signal on the program, on the executing program, you'll receive an interrupt here. And the interrupt that we are looking for is a sig-int signal. And basically, once this is done here, this channel is open, and then we have this execution, we have a cancellation call. And once this cancellation call is called, we have this context.done being supplied somewhere else, which is here. And this server basically has to shut down once this cancel is called. Basically, that's how we are laying it out. And basically, what does a serve look like? It takes in the context, of course, the cancellation context. If we have this CTX here, we have the done here. And basically, once the cancellation is called, this gate is open and we have this block getting executed. Until then, it will be basically blocked here. And if you look at here, we have the HTTP server. And we do have a way of shutting it down just by using the server's internal endpoint, which takes in the context. And this context follows the same rule that we discussed earlier, that cascading rule. If the parent context is canceled, everything is canceled, as in the context passed here is also listening to the done. And once the done is done, it shuts it down itself, and then we have an exit. So this is how we lay the shutdown. So this is not limited to this. You can, of course, have your own consumers or workers listening to this context. And in case your application is shutting down, you might want to have some graceful way of letting the consumer know that it has to shut its operation or finish off the operations that you're doing right now, so that we're not left with some kind of a stale state once this shutdown occurs. And then it can exit properly from there. So I'm just running through a demonstration. We have started a server here, and then I'm gonna go back and basically call an interrupt and shut it down this way, so that once the interrupt is called, the server is trying itself to shut it down in a cooperative way, and then finally exits it. And you can place in your own logic in this place, take this context here, listen to the done, and shut your server down, and be done with it. So this is what the third use case is all about, the graceful shutdown. Now let's get into the good, bads, and those things of the context itself. So let's get into the good. So the point of context is it should the entire the whole point of using the context is that it should only be an operational parameter. For example, if your request is running for some time, you can say that it should run for 2 seconds. It's an operational parameter, or it should run till I say that you should cancel yourself, or you should terminate till I say you to run, using cancellation thing. So it's more of an operational parameter. You can use it to shut your application, etc., do a graceful handling and those things. But it should not be a core parameter for anything. Basically that. And then also the another point here is that you should definitely use it as a communication tool across the boundaries. It's not limited to the same stack. Of course, you can use this context to be passed over the gRPC call. You can use this context to be passed through another API call as well, through the API call. It doesn't need to be in the same stack. And then the other point is that you can optimize the resources. As I talked earlier, is that once you call the cancellation, the resources are released. And that's how we optimize the resources. So if you have this cancellation, you have a quicker and better way of getting rid of resources quickly and moving on to the next request. The other hard parts of every library that we have has a disadvantage in itself. Certain things that may be a little tricky to say. So first thing is that when you do a cancellation, there's no way for the caller to know the cancellation did indeed occur or not. You call the cancel and you are at the mercy of the other end to implement. The same question comes in, how long it takes for that done to get executed. You don't have a way of knowing it. So that's one disadvantage of it. And then the another aspect that I talked about the value is that in value is an interface. So you don't have a way of passing in a strict data type. So you lose the value of it there, as in you're not passing it with the right type. So you have to always hack around, check the type, do extra handling for the values that are passed through the context. And the third part is that if you have noted most of the method signatures that we have with respect to context, it's the first parameter which is passed, and that just bloats the entire function signature. You have the context, you have your own parameters after that. So it could be taken as one of the disadvantages there. And a few of the best practices is that the same thing, just apply the context as the first parameter. That's the most followed way. It also comes in as the first operating parameter that gets passed in. That's one of the best practices out there. The second is that if your function is not request specific, you're okay to use the context.Background. It's okay to use context.Background, but it's not much okay to use context.todo. Don't much use it, or don't really use it into production. It does nothing, but it doesn't look really good. Nobody really does use that much there. The third aspect is that context is immutable. You can, of course, you can feel free to pass it across the functions without worrying about it getting terminated anywhere. And the very important point, you should never persist the context anywhere in the stack, because first thing is that it could be the entry point of any disaster that could happen in your application. Context is pretty specific to a request. And if you're having some kind of a request specific object being persisted in your application in any form, what it means is that you have a way of leaking that info as well. So definitely it's a big takeaway is that never persist context anywhere in your application. And one more point is that it should be always flowing. What it means by flowing is that it should just flow from one method or one function to the another function. But there should not be a way of retaining it in any way. Nobody should retain it. That's what it stresses on. We should not persist it anywhere. We should just pass it on and forget about it, or pass it on and use it in that request and then move on. That's how it should be. And yes, we have finally reached our destination here. This is all about the context. We have briefly touched upon the use cases that it could be broadly used. Any pattern that you see, you can extend it over there and make your endpoint better used, better operated, better maintained. And the slides, I have put it in my GitHub, hosted it here. You can feel free, you can have the same slide. Work on the demonstrations using this repository link and try it on your own, maybe extend it over as you want. That's it from me. Any questions? Anything?
Yeah, I think there's a few questions here. So first of all, I just wanted to say thank you very much once again. The second appearance on Golang Live, really appreciate the presentation and the feedback's really good so far. So thank you very much. If you want to stop sharing your screen, Sudersen, there's been a few questions come on there. It might be easier for you to answer rather than me reading them out, to be honest. So.
All right. So yeah, thanks, Jake, for the good opportunity to get my views and the slides on. So I'm looking at the questions. What will be the impact of calling cancel because differ will execute at the end after the successful execution? So yeah, I'm addressing Kiran's question. What's the impact of calling cancel because differ would be executed at the end after the successful execution? So since we are having a cancellation as differ, what it indicates is that it always goes paired with a timeout as well. So we have a timeout context, we have a cancellation lever. Since we are deferring it, what it means is that if it also gives you a leverage to cancel it before the timeout as well. So certain cases you might want to have a way to cancel the context way before it is timing out as well. So it's more like it can happen before or after, whichever is earliest. So the point is earliest gets a priority. That's why we have this lever as well, and you can use it in that way in your application. Hope that answered your question. I'll go to the next question.
Yeah.
Can you talk more about differences between to-do and background? Why should to-do not be used? So to-do and background are basically the same. If you look at the implementation, it's a nil context. I prefer, it's more subjective topic here, but to me, a to-do would look like when you're releasing something to production. If you go with to-do, it would indicate that there are certain aspects which are still needed to be done. You should rather address it. That's what I prefer. But of course, it's there for a reason. And usually it's better practice to just deal with it. If you're dealing with to-do, deal with it first, than going with to-do. But of course, you can use it in certain use cases where it's not clear, but keep it as your last option. Of course, it's pretty subjective.
Thank you.
Hope that answered your question. I never used context. I'm looking at the current question. I never used context to trace a request across the system. Is it used industry-wide as, are you propagating the derived context as well as? So I will read the question first. I never used, it's from Sunny. I never used context to trace a request across this system. It is used as industry-wide. Are values propagated to derived context as well? Also, it is possible that someone can update the value while implementing a new functionality using with value. So all it's okay. It is a sort of it's not written or etched on the stone standard. It's used by, if you take Yager or OpenTrace, they do have a trace ID being supplied. in that way. And of course, that's the way you should be using it as well, because you're supplying an operational parameter here. You're not doing anything. You're just tracing with the context. You don't need to use your own data structure to supply those trace ID. It's not a part of the request. It's the operating part of request, where you want to use this trace ID to trace something and just pass it on. So context is the best fit for it. Yes, it is an industrial standard, but not really etched on the stone. It's the best way of doing it. And in terms of worrying about somebody editing the value, so as I mentioned in the slide, a context is immutable. You can always add few values in it, but you cannot just override just like that. It's immutable. That's why you can just add on and pass on your values as you like it. Yeah, I'll move on to the next question.
Yeah, please.
I'll go to Ravi Kumar's question. Hi, other than deadline/timeout or manually calling the cancel, is there any other method of canceling a context? No, these are the only two ways. One is you can cancel using the lever that you have, the cancel method, or using the time boundedness. There is no other way. There is, as of now, when I'm talking today, there is no other way of canceling a request other than this, unless you kill the stack and cancel the entire runtime. But that's one part. You don't have any other way, sorry.
Thank you. And the last one so far that we have is from Mohsen here. So
thanks for your presentation. Do you have about the performance of this technique, for example, creating 10,000 context objects? Usually, it's usually the context that we supply. I don't have any performance metrics here, but in my experience, we have used the context a lot. It served as essential parameter of supplying a little bit of metadata and those things. You can, it depends on what context you're using. If you're passing a lot of values in the context, it's going to bloat up. Of course, we should not do it. If you have some kind of a high performance system, don't use that. Otherwise, the structure isn't that big. The channel that you're looking at is just one signal channel is there. It won't consume that much. I don't think it would be bloating unless you're having a lot of values being passed or a very big object being passed as a value. It won't bloat up much. That's what I think, yeah.
Perfect, thank you.
Can context be passed to? Of course, you should be passing to databases. There are quite a few databases out there which has its APIs having the context, and there you can supply the cancel or timeout, and it would work as we want it to work. Sometimes your database might have some configurations there. It's hard to do those changes at the database end, where you can supply the context and terminate it pre-hand. Yes, of course, find such libraries which has a way to supply the context. There are ways, and it's done even today. I'll move on to the next question.
Yeah.
Can canceling a single context cancel multiple coroutines? Yes, of course, because canceling a single context, of course, and depends. Of course, because yes, of course, once you cancel the context, the done channel would be closed, which would be an indicator to the listening coroutine to terminate itself. Of course, you can choose to skip it, but the better way would be handling it and exiting the coroutine, handling those channels. So yeah, of course, you can do that. That's what it is for.
Perfect, thank you.
Can you shed light on context key? I mean, writing wrapper to put and extract key into and from context, and there are some recommendation how to write it. So you can pass. It's laid out in exactly the way it is intended to. You can set in the value to context using the context with value method that we have. So in with value, you are going to supply the key and the value, and that's all. So the writer is only going to write. And once you pass this context, we have a method called as value at the other end. That's the only way the value could be accessed. So essentially what it does is that the caller has the access to write, and the called method has only the access to read. So it's just read only there. So that's how it's meant to be. So otherwise we would have a way it would become mutable. We don't want that. It's immutable in this way. I hope I answered your question.
Yeah, well, that's great. Thank you very much once again, Sudersen, and thank you everyone else for tuning in tonight. I might not have mentioned at the beginning, but the whole webinar tonight was recorded. Everybody who attended will receive a link. Obviously, on the last slide Sudersen provided for us, he gave where we can find the slides if you wanted to go back and see them yourselves as well. So, yeah, like I say, everyone will receive a full recording of the webinar. Thank you, Sudersen. Thank you, everybody, for joining. I hope you have a fantastic evening, and we'll see everyone soon, I hope.
Thank you so much, guys. Thank you
No worries.
so much for your time, guys.
Take care.
Have a nice evening.
Yeah.
Bye.
Bye-bye.